Now it's your turn to simplify two expressions using the exponent rules. If you've not done so already, please pause the video and try to work out these two examples on your own first, then return to the video to verify your work. In example A, we have 4 to the negative 2, x to the negative 3, all divided by 4 to the negative 7, x to the 6, y to the negative 5th. In the video here, I'm going to approach this using two different methods. While there are many different methods you could possibly use, there are two that are going to be the most common that people would choose to use. One of the most common options that people would use would be to jump straight into the quotient rule, meaning I'm going to subtract the denominator exponent from the numerator. So 4 to the negative 2 divided by 4 to the negative 7 becomes 4 to the negative 2 minus negative 7. X to the negative 3 over x to the 6 becomes x to the negative 3 minus 6. Y to the negative 5th is a little bit curious. What you want to remember is there are no y's up in the top, so I could fill in a y to the 0, remembering that y to the 0 equals 1. So to write this out, I would have y to the 0 minus negative 5. If we go ahead and do those subtractions, negative 2 minus negative 7 on the 4 gives us a positive 5. X to the negative 3 minus 6, negative 3 minus 6 is negative 9. And y to the 0 minus negative 5 becomes a positive 5. As a final step, we'll notice it tells us to not leave negative exponents in our final answer, so anything with a negative exponent will need to drop down and become its reciprocal, so x to the negative 9 will become x to the positive 9 in the denominator. But anything with a positive exponent is going to stay put. 4 to the 5th, y to the 5th will stay put in the numerator. This gives us a final answer of 4 to the 5th, y to the 5th, all over x to the 9th. Another approach that people can take on the same problem is, instead of dealing with quotients and subtraction, is to first take your quotient that you're given and use the reciprocal of anything that has a negative exponent. So working my way across the numerator, I have 4 to the negative 2 as the first factor. Well, that negative 2 tells me that 4 squared really belongs in the denominator. X to the negative 3 in the numerator, that negative on the 3, tells me x to the 3rd belongs in the denominator. Now approaching the denominator, 4 to the negative 7 in the denominator tells me really that's 4 to the 7th in the numerator. X to the 6 has a positive 6. It's in the denominator, so it will stay put. And y to the negative 5th being in the denominator tells me I should be working with its reciprocal, so that should be y to the 5th in the numerator. So the first step, instead of dealing with subtraction, is to move the negative exponent factors around, move them to their reciprocal location. Now we'll go through and simplify. 4 to the 7th in the numerator and 4 to the 2nd in the denominator. 2 of the 4's will cancel, so of those 7, 5 will remain in the numerator. Y to the 5th is the only y base around, so it's going to stay put. And in the denominator, x to the 3rd, x to the 6th, well, those will combine to give me x to the 9th in the denominator. Notice that either approach gives you the same answer. You're going to need to find which approach you are more comfortable with. And the starting point on that second approach was to identify anything that had a negative exponent and move it to the other side of the fraction. On part B, we have the quantity negative 3 t to the 4th u squared all over t to the negative 2 u to the 3rd, in parentheses, all of that in parentheses, raised to the negative 3rd. Order of operations, we should probably simplify what's inside the parentheses first before we try to deal with that negative exponent. Again, you do have your two approaches. The approach I'm going to start with is moving anything that has a negative exponent. So I circled that t to the negative 2 in the denominator. That's the only negative exponent in the inside of this expression. So that's the only thing that's going to move. So the numerator was negative 3 t to the 4th u squared. That's all going to stay put in the numerator. But t squared is now going to get bumped up to the top. Whereas u to the 3rd was a positive 3 in the denominator, it's going to stay put. All right, now the next step would be to simplify what's inside the parentheses. Negative 3 cannot interact with anything, but up in the numerator, t to the 4th, t to the 2nd can simplify down to t to the 6th. And with the u's, there's u squared in the top and u to the 3rd in the bottom. Well, 2 of the u's from the top will cancel with 2 of the u's from the bottom, but I will still have a single u remaining in the denominator. Now that we have simplified inside parentheses, we're now going to deal with the exponent that's outside. We will apply that outer exponent across the numerator and across the denominator. We'll have negative 3 to the negative third power, t to the 6 to the negative third power, and u to the negative third power. Well, I would be inclined to first simplify that t to the 6 to the negative third before I try to do anything else. So I'll keep negative 3 to the negative third in the numerator. T to the 6 to the negative third becomes t to the negative 18, and that leaves us with u to the negative 3 in the denominator. As a final step of simplification, simply because, again, the directions say do not leave negative exponents in our answer, we will now move things around again. Negative 3 to the negative third in the top becomes negative 3 to the positive third in the bottom. T to the negative 18th in the numerator becomes t to the positive 18th in the denominator. U to the negative third in the denominator becomes u to the positive third in the numerator. And the final thing we might be inclined to do is to simplify negative 3 in parentheses to the third becomes negative 27. So our final answer is u to the third over negative 27 t to the 18th.